Hello and welcome to the Concept 21 Teacher Talk. All right, so when we're getting started with these, we want to pay attention to the fact that they're asking us to perform each of the operations and determine the domain of the result. So if you guys remember that we talked about in class that the domain, we have to first off look at the domain of each of their original functions. And there was two things that we looked at when we were talking about domain. Number one was you check and see if you're taking an even root of a negative number. And the other thing that's going to have a domain restriction is if you have a variable in your denominator. Okay? And so when we look at both of our originals, f of x has neither of those things. So its domain is all real numbers, and same with g of x. There's no negative roots of negative numbers, and there's no x in the denominator. So both of those have domains of real roots. And next, we're just going to perform the operations. So when they say f plus g of x, remember that's the same as f of x plus g of x. So we're going to substitute those functions in, and then just combine like terms. And again, when we look at the final solution, 2x minus 6, there is no, the two checks, there's no even roots of negative numbers, and there's no variable in your denominator. So our domain remains all real numbers. Okay. On part B, f divided by g of x is the same as f of x over g of x. So we're just going to plug each of those in. We're left with x over minus 5 over x minus 1. We can't simplify that in any way. So now we're just going to look at the domain. We do have a variable in our denominator here. So we're going to take our denominator and state that it can't equal 0. And we're going to solve. So we know that x minus 1 can't equal 0, so we solve for x. And we find, by adding 1 to the other side, we find that x cannot equal 1. So our domain is all real numbers except x equals 1. For this one, the next few slides are going to be using the same f of x and g of x at the top. So we're going to check the domains of each of those. F of x, no even roots of negative numbers, so it has all real numbers and nothing in the denominator. And then for g of x, same thing. So it's also all real numbers. So when we're doing composition of functions, we're going to be plugging one function into the other. Okay. So g of x is going to be replaced with 2x squared minus 1. So we're doing f of 2x squared minus 1, which means that in the f of x function, we're going to take 2x squared minus 1 and plug it in for x. So we'll end up with 5 times, instead of x, we're plugging in the whole value, 2x squared minus 1 plus 6. Then we're going to distribute the 5. When we distribute the 5, we end up with 10x squared minus 5, and we bring down the plus 6, and then combine our like terms, and we're left with 10x squared plus 1. And again, on this one, there's no even roots of negative numbers, and there's no variables in the denominator, so our domain is all real numbers. Part B, this time we're doing g of f of x. So it is important to make sure that you pay attention to the order, because the last one was f of g of x, and this is g of f of x, and you're going to get different values. So this time we're going to plug f into g. Okay, so we're going to be doing g of 5x plus 6. So in the g function, we're going to plug 5x plus 6 in for the x. And we're left with 2 times 5x plus 6 squared minus 1. Remember your squaring binomial square patterns. If you don't remember your binomial square pattern, you can make yourself, whoops, that's not what I wanted to do. You can make yourself a box, and you can do 5x plus 6 and 5x plus 6. Okay, but the pattern, if you remember, is square your first term, so 5x squared is going to give us 25x squared, multiply the 2 and double, 5x times 6 is going to give us 30x, double gives us 60x, and then square the last. So when we do that, we end up with 2 times that binomial squared turns into the trinomial, 25x squared plus 60x plus 36. Then we're subtracting the 1. We're going to distribute the 2. When we distribute the 2 and then combine the 72 and the 1 to get 71. Again, there's no binomial or negative, even root of negative number and no variable in the denominator. So our domain is just going to stay all real numbers. In our last example, this time we're doing f of g of negative 1. So we're going to find the value of g of negative 1 by plugging negative 1 into the g function. And then we're going to take the answer that we got as our output, and it's going to replace the g of negative 1, so we're now going to be finding f of 1. F of 1, when we plug it in, we get 11, which means that f of g of negative 1 is 11. Okay, if you guys are still having any questions, please let us know, and we will be happy to help.